Number 14 is a common ion problem. So let's take a good look at this. This is going to be, obviously, this is going to be equilibrium, so we're going to use ice. But before we get to that part, though, we got to figure out what's going on. It says a solution that is 0.16 molar of sodium formate, and 0.26 molar of formic acid. So let's start with the acid on this side, like we always do. So it's CHO2, like that. I'm going to add that. Well, I'm not going to add to water. I can just go through like this. It's not that big a deal to get the H plus here and the CHO with a minus like this. Now once we have this set up, I got to do my ice. I'm going to do this very quickly. Remember, we're going to be crossing off stuff because of the 5% rule. So let's whip through this so this number 14 doesn't take too long. I'm going to have you do the last one then. So the initial concentration is given to us. It's 0.260 concentration for that. It's 0 for this, and it is 0.16 molar concentration for this, because that means that. Okay? So the change is going to be a minus on this side, it's going to be a plus on this side, and a plus on this side. I get here with the equilibrium, obviously, I get that, and I get that. Now here's the part that I love. I love the fact that I don't need to worry about that, and I don't need to worry about that because X is going to be so small that it's not going to make a difference. That means that for my Ka, now here's the part where it says use Appendix D, Ka is 1.8 times 10 to the negative 4. Good, just want to make sure I had that right. And the Ka equals, I'll write out this time, the concentration of that and that's a minus, all over the acid, like that. And we plug in the numbers, and what we end up with is 0.160. Remember, I got rid of the X there. And then, in other words, I keep this X but get rid of that X. That's what I'm talking about. And then I divide by 0.260 like that. When I solve, then, what I end up with is X equaling, because I'm going to, obviously, I'm using this number over here, and I'm going to multiply both sides by this. I'm going to divide both sides by that, and I get X equaling to 2.93 times 10 to the negative fourth, to the negative fourth, which means that's what my hydrogen ion concentration is. So pH is equal to the negative log of the hydrogen ion concentration. So that equals a pH of 3.55. 3.53 is what I got. 3.53. That's the answer they're looking for. Okay? I would like you to do the same thing for letter C, but we're going to scroll down and do letter B, and then you can handle the next one. Ooh, that is not a lot of room. So here, I have to do, here's my pyridine. So this will be, let's start on the left-hand side with my pyridine. C5H5N plus water. I have to do water this time because we have to throw out the OH, or we have to separate it into the OH. So that means that I get C5H5N, where are we at here? N with an H plus, like that, plus OH minus. So that's how the water split up, with the H plus and the OH minus there. So we're going to do our initial change and equilibrium. I'm going to kind of squeeze it all together. This one starts off with 0.21. This one here starts off, because that's what this is right here, is this concentration, which is 0.350. This one starts off at 0. We're not counting H2O. The change is a minus, plus X, This gives us x. This gives us 0.35 plus x, but I can get rid of that. This gives us 0.21 minus x, but I can get rid of that. So these two go away because my KB in this case is given to us as 1.7 times 10. Where's it at here? To the negative 9. So this is going to be a really small number. Good. So we're in good shape. That means that what I have here then is the C5H5NH plus, like this, times OH minus, oops, like that, all over C5H5N, concentration of that. And then I simply plug them in without the minus x and plus x. So what I get then is the 0.350 times x divided by, you're going to see the same pattern. It seems like the same thing's happening over and over again. I solve for x in this case, but this x in this case, though, is going to be the hydroxide ion, not the hydrogen ion. So it means we're going to have to do a little bit extra math at the end. So what I get then is 1 point, that means x equals, let me make that specifically clear, x equals 1.02 times 10 to the negative 9th, like that. Okay, that's the hydroxide. So the POH equals the negative log of the hydroxide, which is what we have there. Sorry, it's getting wavy. So the POH is 8.99. So we simply take 14 minus that, which means the pH is equal to 5.01. Okay. All right, I'm going to do a second part to this, and it's going to be C, because